Hello everyone, both here and at home. Happy International Women's Day. I don't know if it's a coincidence, but there's only one man besides me in the room today, Irene. So, good turnout from the female contingent. Okay, so today we will slightly change the order of things. I'll start lecturing as always, but I'll stop short around 1 to let group 11, paper 11, present, since they have some conflict. So we do that, and then we will take a break, and then we will have group 10 present after the break, as we generally do. So let me get on with the new deck of slides. So far, we've been mostly talking about game theory, behavioral economics. This was the early lectures, social interactions, and all the game theoretic approaches to modeling social interactions. We have talked about different games. We have played some of these metaphors of cooperation and coordination. So the focus has been very much either theoretical or applied in the laboratory. So today I'll try to draw some conclusions about what can be learned in the laboratory experiments and contrast that with a new strand of economics that tries to bring that level of randomization and that methodology to the field. So as we have already discussed in previous lectures, a concern with laboratory experiments may be that they lack external validity. In some of the presentations that you put forward, this emerged, the sample being somewhat skewed, oftentimes students, oftentimes in the West. So in order to overcome these limitations, field experiments using randomizations, randomized control trials have also been introduced so that the subject, the participants, are immersed in a more natural environment. In fact, they may not even know that they are part of an experiment. They may be simply doing their activities, say fishermen actually fishing rather than us playing a computerized version of this game, capturing such trade-offs. So this is going to be a link between the lab and the field that will give us an opportunity to contrast strengths of both methodologies and see how they fit in the broader perspective about experimentation. Two important readings that are related to this part of the lecture, one by Bodo Sturm and Joachim Weimann in Journal of Economic Surveys. This is a review about experiments that have been applied to the environment. And then more on the field experiments, John Least and Michael Price have also a review that focuses on experimental and resource economics, but with a greater focus on field experiments. So first, some tips about what are good ideas about things to do in the lab and what one should try and avoid. And then, as I said, we will move into the field where actually actors play the real-world game, so to speak. So if, say, you want to do an experiment, it could be part of a dissertation or of a research project, it's probably a good idea to ask yourselves these 8 questions, possibly more, but this is just a way to get us going about thinking about the implications of design in terms of what you want to elicit. So first and foremost, may seem overly basic, but it should be a good idea to have a clear hypothesis about your research question, and importantly, if that question can be addressed by the experiment. And in order to keep things simple and focused, it's probably best to just keep it super short, one sentence answer. If you cannot give a very concise answer to the question, then it means probably this kind of design or your ideas need to be sharpened. Secondly, one should be reminded that there's many ways to tackle a given research question, and it needs not be experimental, the approach. One could use secondary data, or perhaps similar experiments have already been done, so you do not want to redo experiments unless the point is a replication study, so you try to assess the validity of the first, but as always start from the literature, also outside of experiments. Then, given the question still stands, it is still open and up for debate, the literature has not resolved it yet, how do you tackle that question? Is this the best possible way to go about it? Again, this needs not be confined to experimental methods, but everything that one is aware of, at least within the realm of your field of studies. Then it would be probably good to come up with a list of pros and cons of going this way. So what does an experiment, why is it better fitting your research question than an alternative method, and what are the cons? Do you really care about this research question? It takes time and effort and money to do it, so if it doesn't get your excitement up, then it probably means this is not worth studying. What are the chances that the answer you get from the experiment will surprise you or others? This is an important question. Of course, I'm not suggesting that we should only do things that give us surprise answers, but certainly interest and the potential for unexpected results can be a plus. Can it actually make a difference to somebody else's mind? Can these results inform and change behavior or attitudes? If you are clear about those five questions, and you think it's a question and that can be addressed in an experiment, and this is the best tool that can tackle such questions, then it's always a good idea to be pragmatic and think about the steps and how you go about testing your research question. And there's nothing better than actually writing down your design and, importantly, the instructions that you give to participants. Right? You may think that you have a clear idea about how you test your hypothesis, but until you have written it down, especially the instructions, what you would read out loud to the experimental subjects in the lab. Oftentimes, many subtle, nuanced questions do not emerge, and that includes, for instance, the exact payoffs, how the timing affects the choice, what level of information do they get. If it's a multi-round experiment, do you give full disclosure, or do you withhold some of the outcome in order not to influence the following round? These are all, there's no right or wrong answer, but these are all consequential, given that, as we have seen in many experiments so far, the type of information you show is of essence also in terms of future behavior. So if you are interested in a situation that is best described under conditions of common knowledge, it makes sense that you provide the entire feedback if that's realistic. Otherwise, you might want to not disclose the full picture. Question 7, is your experimental design the simplest possible design to help answer the question you have stated? This is probably the trickiest question to address. It's very easy to come up with very complex designs, but then it might be very difficult to make out something of it, given that you don't know exactly what is driving the results. Remember, simplicity is key in the lab. You don't want to confuse participants, but also you want to only change one thing at a time when you compare different treatments. Otherwise, again, you're confounding multiple drivers of behavior. And so you want to refine your design to the bare minimum so that you still capture the basic underlying trade-offs, yet you have some generalizability and external validity as well. So always keeping in mind the compromise between internal and external validity. 8, what are the possible outcomes of the experiment? This again may seem a rather obvious question, but actually it takes quite a bit of planning to come up with measurable variables, right? So before going into the lab and just see what happens, it's an excellent idea to think, okay, here's my research question, cooperation under this treatment increases or decreases depending on what you are interested in. Okay, but that's not enough. How do you measure cooperation? What is going to be your outcome variables? And what kind of data is the experiment going to produce so that you can either falsify or validate your hypothesis? Something I should have added before at the beginning when I spoke about the hypothesis. A good hypothesis is one that is falsifiable, right? Such as treatment 1 increases or decreases, so a directional hypothesis on the outcome variable of interest. In the previous example, cooperation rate. If you state vaguely that treatment 1 will affect cooperation rate, that is not a directional hypothesis, it's just a very ambiguous statement that is hard to falsify, right? Basically, both a positive direction in terms of treatment effect or a negative one would qualify as a change. So the only situation in which you falsify such an hypothesis is the null effect in which nothing happens to the outcome variable. But you see, that's one possible outcomes out of many that allow for growth or decrease in cooperation. So be more specific as possible, and think about how you test these outcomes and what variables are contained thereof. Questions on these 8 good practice questions about running a lab? I should add that we've been always talking about laboratory experiments, but technology has evolved, and especially a big acceleration came in the last 2 years because of the pandemic, where many activities were shut down, including laboratories, such as the ones, by the way, Bologna University has 2 laboratories, one in Forlì and one in Bologna, the BLESS lab. So we do physical experiments with students. You're very welcome to participate and be compensated for that, but also us, and not just us, but in general, experimenter academics, increasingly, depending on the research question at hand, have been also relying on online pools because you can, generally there are advantages. They tend to be cheaper to run because you pay people a bit less on average, since they do not have to come to the lab, etc. There's another pro in that you may have a more representative sample. When I say you may, it really depends on what kind of sample you're interested in. If you want older people, probably going online, recruiting people on Amazon Mechanical Turk or other panel providers such as Prolific Academic or Lucid. There's a bunch of such online websites. Then probably is not the best way, right? If you're interested in 50 years old and older, because there's not that many people online among this strata of the population. But if you're interested in a not necessarily representative sample, but still more representative than only students, you may want to go online. And as I said, it's also faster to recruit large numbers. So if it is going to be a large experiment, for instance, or you're pressed with time, there are some advantages there. Point being that the division between the lab and the field is becoming increasingly blurred, but for academic and pedagogic purposes, I'm keeping the distinction very neat. So far, lab experiments generally with students. Today, then, we will talk about field experiments in the field, but I want to also throw out there the fact that we can also do lab in the field or online survey experiments using people recruited online, also representative samples if needed. We have seen it in some of the presentations. This has been the approach followed. It all depends on your research question and the kind of subjects you're interested in. Of course, one great thing about the traditional lab experiment is that it gives you great control, great internal validity, given that you, as the experimenter, read the instructions generally out loud. You make sure that people understand by having test questions that one cannot advance to the actual experimental phase until one has correctly addressed. Subjects can raise their hand if they're confused, and they can get further explanations. Online you have less control, but you can still put attention screeners and control questions so that if people are just clicking at random and they're doing other things, you can screen them out of the experiment. As a final note, before we proceed, I mentioned the dissertation project. Some of your colleagues at RESD in the past ended up doing experiments online, which is generally preferred for cost reasons, time reasons, and also given that it is a sort of student project exercise and not aiming at publication. It is generally okay to use a sample such as your peers, so you may do it online with your colleagues. So depending on time, we might have a former student talk about his experience doing one such online game. All this to say that with a little bit of software programming skills, this can be done relatively simply and completely free or very cheaply, depending on how much you want to reward your participants. So if there are no questions or comments, I will continue in my gradual move towards the field. Here's the last question I had as part of Q8. Do the possible outcomes include at least one outcome that will answer the question you stated above? If not, then probably either change the question or change, most likely, the design. And what is the chance that you will actually observe this outcome? This, again, may seem like a trivial question, but especially in small laboratory experiments where given cost limitations and time limitations, for instance, in Bologna in the lab, we have 40 computers and 40 partitions, cubicles, where subjects sit. So that limits the number of sessions you can do, right? Let's say that it is a massively large group. You need 20 people, which for lab experiment is very large. That means in a given session, say from 2 to 3:30 p.m., you can only accommodate 2 groups of 20 people each. So why am I talking about this? Because this has implications for the statistical power to detect the signal. I think I'm recording the lecture. Yeah. All good. It's on Panopto. So the sample size, right, especially insofar as it is a group condition, it is a group exercise, like a public goods game. Let's say we're playing a public goods game, except it's not groups of 4, like the ones you have been playing on MobLab, but it is groups of 20. That means that one independent, in a given session, we have said that there are only space in that lab in a given session for 2 groups of 20 people each at full capacity. That means that in a given session, you only get 2 independent observations. Why 2 and not 40? Because the public goods game being a group experiment, your choice is dependent also on the choices of others. So a really true independent observation is at the group level. That means if you want to get 10 independent observations, you need 10 groups, you need 200 people. You see how that becomes a limiting factor. So one, before doing the experiment, can do statistical power calculations to see what would be the sample size, there are some rules of thumb, that would allow you to detect a signal, to detect a treatment effect under plausible assumptions. So you need to have enough statistical power in order to detect a signal. Otherwise, if you get a null treatment effect, the fact that your treatment doesn't affect the outcome variable, you don't know whether that is because the treatment is actually not able to change people's behavior, it's too weak, or your hypothesis is wrong, or perhaps simply the study is underpowered to detect the treatment. That's why you need to do all this reasoning before. So these experiments seem very simple, yet they take quite a lot of planning ex ante. Okay, so if there are no questions, I will proceed with the field, or going from the lab to the field, and then draw some conclusive remarks. But first, let me talk more generally about measurement, given that experiments have a big advantage, both field and lab have a big advantage with respect to secondary data, in that you can construct your counterfactual, which is something very elusive in real life. We often do not know what would have happened in the absence of a policy, simply because the policy was enacted and we know the world as it is after the Paris Agreement. We don't know how it would have been without such an agreement. In the lab, you can do such a thing, right? The control group is the world without the policy. So if we could observe the counterfactual directly, then there wouldn't be any evaluation problem. You simply look at the difference between the two outcomes. Sometimes this is possible, and that is the case, for instance, of natural experiments where conditions are such that you have a pre-treatment and a post-treatment situation in the wild, in the field, but oftentimes this is not the case. The various approaches using naturally occurring data provide alternative methods of constructing the proper counterfactual. That's why we like to do experiments. Let's talk a bit about the data generation process, and in particular, let's come back to this idea of internal validity and control. So on the left-hand side, we have the lab, which gives us great control and maximum control about the way you create your data. You create it artificially yourself, and you set up the treatments in by using the tools of randomization and random assignment to treatment in such a way that you can causally establish a link between your treatment and the outcome variable if you find an effect. In the real world, in the field, we have naturally occurring data, which is very interesting, of course, but lacks that degree of control. So we will discuss briefly some of the tools or some of the possible experiments. Natural experiments I've already mentioned, naturally occurring without intervention by the experimenter. You can think about more econometric techniques to deal with secondary data, such as instrumental variables estimation or structural modeling. Very briefly on the history of this field in economics, one can think that experimentation began with Bernoulli. This is not the mathematician Bernoulli, this is or probability theory. This is another one, Daniel, which seems to be the first to run a large-scale experiment about the St. Petersburg's paradox. Just as a fun fact, this tended to be quite in line with expected utility theory, so the rational actor model. More recently, in the 30s of the last century, a big focus in economics was given to individual choice and testing neoclassical theories, including ordinal utility theory, with experiments not of the lab kind, but more thought experiments. Later, midway through the century, a great deal of interest in terms of experimentation was focused on markets, including testing the competitive equilibrium ideas from neoclassical economics using induced values. So using the experiment as a tool to infer the prices of goods in markets. And then finally, with the advent of John Nash and his dissertation from the 50s, which was published in the Proceedings of the National Academy of Science, a great deal of interest about the Nash equilibrium and the empirical validity of such theory, and in general about competitiveness versus cooperativeness came to take over within economics in terms of experimental work. Now, to look at dynamics in terms of how many scientific papers have been published in a given year in the field of experimental economics, you see that especially and possibly due to the foundation in the US of the ESA, the Experimental Society, which was founded in the Mannheim meeting, the interest in the field grew exponentially also because it had a name. Until then, people were doing experimental economics, but there was no scientific association. I should mention that not only, as I've already told you, I think the University of Bologna and myself are organizing the Environmental Economics Association of the European Society for Environmental and Resource Economics. That's going to be in Rimini at the end of June and beginning of July here. But a month later, at the end of August, beginning of September, we will host the ESA Experimental Economics Conference in Bologna, this time not in Rimini, again organized by us at the Department of Economics. So if you're interested, that's going to be another high-level international conference within 100 kilometers from here. In terms of actually top journals, which of course are very important for academics working in this field, you see that there's been a quick rise, mimicking the general trend in total publications in experimental economics. So what is an often heard criticism of laboratory and field experiments, but especially laboratory experiments? Here's a quote from John List, one of the big proponents of lab and field, more recently field experiments. He used to work at the White House as a consultant as well, and being so prominent in the field of experimental economics, is an American academic. He tried to push for the usage of lab or some lab findings, the most consistent ones, also to be considered when revising cost-benefit guidelines within the government of the United States. And this is the response from a colleague at the White House. Even though these results appear prevalent, because he was quoting some that are highly replicated, they are suspiciously drawn by methods similar to scientific numerology because of students who are not real people. So this is going back to the acronym for Western educated, industrialized, rich nations subjects. So there's some diffuse criticism. This is another one by another individual. It seems to be extraordinarily optimistic to assume that behavior in an artificially constructed market, quote-unquote, game would provide direct insight into actual market behavior. This especially because in the 70s and 80s, there was much interest, again, by another, pioneered by the efforts of another Nobel Prize awardee in economics on market behavior and using experiments as a test lab for markets before, for instance, introducing such markets. So you can imagine before opening up the market for TV frequencies or energy markets, you can use laboratory tools to try and assess what would happen in the real marketplace. So again, not people have a problem with using such market games in this line of skepticism. And more generally, this debate between hot versus cold in terms of commodity stakes or even the environment, or conversely about short-run versus long-run tasks that do not necessarily carry on so well outside of the lab. So maybe in the field, people tend to behave in a more impulsive way, and so if that is the case, the external validity would be limited. Vernon Smith, the Nobel Prize winner that did a lot of research in the lab on markets, responded to such criticism in one of these top economic journals in economics, the American Economic Review. In 1980, he wrote, "Experiments are sometimes criticized for not being realistic. Are there field data to support this criticism, i.e. data suggesting that there may be differences between the lab and the field behavior? If not, then the criticism is pure speculation." So I think it's interesting because what Vernon Smith was doing was turning the tables around. He was saying, okay, if you don't prove to me that there is consistent bias in what is found via experiments, then I shall assume that they are correct. Why should it be not the case? So this got to really sort of a war of attrition between two camps, those that like experiments and those that do not see value in them. This is often self-serving, right? With people that are more invested, like John List, in experiments, being on the defense side, and people that use, say, secondary data as a preferred tool, such as econometric techniques, trying to push for the status quo of defending their previously uncontested territory. And that includes also some economic theorists, because you can see that, until the 80s, economic theories were pretty much largely untested. I'm talking about the rationality assumptions, all the stuff that we have discussed in the first few lectures, and all of a sudden you have a new tool that allows for this kind of tests and often demonstrate that we do not accord, or our behavior does not accord well with that of the rational model prediction. So that got a bit polarized, and one way to help inform this debate is to run field experiments. And so in more recent times, in the last 2 or 3 decades, there's been an advent of so-called field experiments. Here's a bit of the schematic representation of the basic idea behind field and lab experimentations. They, like lab, also in the field, the methodology relies on randomization as a crucial tenet, selecting strata of the population, of representative samples, ideally of the population, or at least for the target group that you are interested in. And importantly, the third pillar is that of replication. Much of these experiments have been replicated or failed to replicate, so that provides a test of their validity. And as I've already mentioned, an important aspect is having enough statistical power such that you can run good statistical analysis. I shall add that unlike secondary data, which is much more noisy, one good thing about both lab and to a lesser extent field is that the data tends to be very clean, right? Because you design in a way which data you will get, and it is very easy to analyze. So often you don't need very sophisticated econometric models, but rather basic OLS will do the job, given that you don't need to worry too much about randomization if you did it properly. Questions? Okay, questions that led to a second wave of so-called social experiments. And these, beginning in the 60s, have changed the way that experiments have been done, including very prominent and large sample tests in the US first, and more recently also in Europe. I already mentioned that in the 60s we had pricing schemes run in Great Britain using experiments before deploying them in the actual real world, so to speak. So beyond showing the power of randomization, the profusion of social experiments has helped to kick off a series of methodological debates between the different camps in economics. So going back to the earlier criticisms, one response by people that rely on randomization is that plots of lands cannot excuse themselves from treatment, right, or select whether to be available for treatment. There's no selection bias. More broadly, this touched off the debate between the econometricians, especially structural ones, and experimental advocates, and this continues today. So this is just to show that this is very much a lively debate, and it hasn't been resolved. I guess both methodologies coexist. In that spectrum between maximum control in the lab and data naturally arising, we have these kind of three field experiments. Let's begin from the very left-hand side. You know very well by now what conventional lab experiments are about. They utilize a standard subject pool, generally students, generally an abstract framing, and a given set of rules, right? You say, like when we played the fishery game yesterday, the resource doubles every round, provided that you do not go below 80 fish. These are the rules of the game. Or in the public goods game, this is the return to the collective investment. That's 40%, 50%, etc. So that's on the lab. If you move one step towards the real world with artifactual field experiments, AFE, it's effectively a conventional lab experiment still, but using a non-standard pool. So let's say that you're interested in the behavior of fishermen. You can recruit fishermen, and they come to the lab, so it still has the same characteristics of a standard lab experiment, probably framed with a given set of rules, but now your actors are not students, but they are the population of interest. Then you have a bit to the right the FFE or frame field experiment, which is an artifactual field experiment, but in this situation you're giving field context, for instance in the commodity, if it's a market game, on the task, information in terms of stakes, time frame. So we are abandoning this very abstract and highly internally valid and controlled setup to have more realistic features of the problem you're interested in, but of course you're giving up a bit of control when you do that. But sometimes, as we have discussed, the problem may be too complex or too abstract to present it in an unframed manner. So in that case, you opt for a frame field experiment. And finally, the sort of El Dorado of these more field-based experiments, a natural field experiment, is the same as a frame field experiment, but where the environment is the one that the subjects naturally undertake these tasks in, so that the subjects do not know that they are in an experiment. So this is very powerful in a way because you observe actual behavior without having all these biases potentially are induced, such as experimenter bias, that people tend to do something because they may form an idea about what the experimenter expects from them. Here, people are not even aware of being monitored, and they go about their lives, but thanks to some natural occurring phenomenon or policy, you still get these data in an experimental way because there's still the element of randomization. So to make it a little more concrete, think about which, by the way, I think in Italy there's going to be a new wave of that. Think about when the terrestrial digital TV was introduced in Italy, but that I think applies to most European countries. In Italy, it was done gradually. So, if I remember well, they did it by region. So at some point, before we had the analog TV, right? And then we transitioned to the digital one, which requires some kind of decoder, and it allowed for many more channels, TV channels. So there's a literature that has exploited this naturally occurring. Of course, it's not natural in the natural sense. It's not a natural event, but it is done for purposes other than your experiment, right? It was the government that decided this is a good idea. It will yield more space for different frequencies, more channels, dedicated news channels, for instance, proliferated afterwards. So that's the outcome. And the policy was done gradually by region or groups of regions. So, for instance, there's some papers in economics and political science that look at perceptions about crime in Italy due to this gradual intervention. Because the intervention was decided by the government for other reasons, it is effectively a random partition of the total population into groups. Let's say that the first region was Sardinia. In that case, people in Sardinia were exposed to more channels, including dedicated channels about TV news earlier on. And then you can look at perceptions about crime rate by these people under the assumption that they will watch more news, and the news tend to disproportionately talk about crime, and so that may alter their perception about crime. And then you can compare that to the control group, which is those that have not switched yet, and then see when they switch if perception changes. This is a natural field experiment, just to fix ideas. Any questions? So a deeper economic understanding is possible by taking advantage of the myriad of settings in which economic phenomena present themselves. In many cases, experimentations in small-scale field setting is very useful in developing a first understanding when observational data is limited, or experimentation is in more important markets is not possible. So this is potential different usages of these methods. After which one explores how the key features of the study domain compare to more distant domains. So this is also to make the point that all these methodologies are complementary and can leverage different pros about the type of data you have at hand or you aim to construct. So let's be more specific about how field experiments have been used. Like lab experiments, they've been used to test theories, to measure key parameters, say inequality aversion, to mention one that we have encountered prior to this lecture, to collect information to eventually construct a new theory, or to speak to policymakers. If we have time, I will talk about one such field experiments about energy that is very salient and relevant from the point of view of policymakers, and also to generate income. So that's more on the testing point of view, but there's also methodological contributions. For instance, much work, including by John List in another top journal of political economy, trying to establish whether the two, lab and field, are good predictors of one another. So in which case that would give increased validity also to laboratory experiments. If, say, going back to actually not this one paper, but there's one also in the same journal that does precisely what I was talking about before on the fish. The lab experiment on an abstract game like the one you played last time, and then they did a field experiment with a similar setup but on a recreational lake in Holland to look at behavior by actual experienced fishermen, and then they estimated to what extent the two correlate. Related methodological contribution is about the role of the market, so experience in the market in mitigating various forms of behavior. We will see that in a second with the actual example. So in general, this literature tries to answer the big question whether we are making proper inference from the lab, given the extensive usage of laboratory experiments, and also naturally occurring data. So related to inference, let's look at this example. Field experiments might highlight that certain results from lab experiment or from naturally occurring data, the secondary data that we generally use, should be defined more narrowly than first believed, or even might cause the initial insights from the lab or the field to be reinterpreted. So let's look at one such experiment about the endowment effect. This is the one where you give half of the class, say here, mugs, and half of the class candy bars, and then you let the two parties trade. The general lab finding is that people, as we have seen in the early lectures, people tend to give more value to what they are endowed with, even if it's completely arbitrary, the fact that one receives the mug or the candy bar, but your willingness to accept tends to be higher for the other good, even if it is of comparable value, than your willingness to pay. So this is something that can be tested in the lab, but does it carry on to the field? And another contribution, more academic, is that of making refinements to existing theories. Combining these results with those from the lab, so field and lab, to use distinct observations to create a deeper theory, more accurate of human behavior than only using lab or field could do. So there's a big literature on that as well. And also, we have already mentioned this, previous experiments happen in different contexts using different frames, and then detail the types of variables that either attenuate or exacerbate the candy bar versus mug endowment effect. You may discover that this was specific to those two goods, for instance. If you were to do it with a different frame or different goods, perhaps you get a treatment effect that is reduced or even stronger. So that was about inference. Let's talk about the causes. Field experiments can shed light on the causes and underlying conditions necessary to produce data patterns observed in the lab or in secondary uncontrolled field data. So here I will show you a simple experiment, again done by John List, about discrimination in another top journal. This is the QJE. So in order to study discrimination, the setup was relatively simple. Of course, this is a field experiment, which generally means smaller samples. In this case, it's a sample of 24 subjects, 12 disabled and 12 non-disabled. And they played the role of testers having a problem with their car. And so they approached, of course, the car didn't even exist. This was a question they had, a theoretical question for the body shop owners in Chicago. They went to different ones, both the two groups, each of them independently, and they said they needed repair for the car. So the type of problem was the same, the type of car was the same. So the only difference was that most likely, given that these people were somewhat, except for the handicap, that there was no distinctive factor about them, so there's good reason to assume that they should be treated equally unless there is discrimination. And when they asked for this estimate about how much it would be to repair their car, the disabled received a 30% higher estimate. So that seems to be evidence of discrimination, right? So they also did a survey analysis which confirm the hypothesis of the researchers that first of all, disabled people, due to their condition, tend to do less research, so they are less likely to go into different body shops and ask the different mechanics for different cost estimates. So that's sort of a fact in the field. It's not about this specific case. Somehow body shop mechanics know that, anticipate that, and also according to surveys, they are aware that the disabled people are less likely to compare across different mechanics. So given this survey evidence, they decided to go back to the field and resend different pairs to receive price quotes. So one treatment is identical to before, it's just a replication treatment. In another one, everything is the same, which is a good rule, except for one thing, that both the disabled group and the non-disabled people added one sentence to the script about what they were to say to the mechanics, and they just mentioned casually that they were getting a few price quotes, right? So in a way, from the field and from surveys, we know that disabled tend to search less, and mechanics anticipate that. So this is meant to offset that, or at least mitigate that that perception by the mechanics that disabled will not go and compare with others. So first of all, they were able to replicate the previous finding. So the estimate that the disabled people got was around $600 for the same job that the non-disabled people would get for only $500. So there's a significant spike and a significant level of discrimination. What happens in the groups that either said few quotes? I'm getting few quotes again. Distinguish between disabled and non-disabled. What do you expect? Will there still be this gap? Will it disappear? Will it go the other way around with the non-disabled getting a cheaper, getting a higher price cost estimate?
I think that it might disappear because they will maybe get a lower quotation, but at the same price.
Okay, due to this idea that the mechanic now knows that they cannot discriminate, right?
Exactly.
Okay, let's see if that was the case. Correct. You see, all of a sudden there's no difference in quotes between the two groups, just adding that one sentence. So you see how this is powerful and how this can be tested effectively in a simple field setting. Okay, are there questions on this experiment or these field experiments in general?
Yeah, sorry, Professor, I have a question actually about the framed field experiment. I didn't quite get the difference between the factual field experiment and the framed one.
Okay, let me go back. No problem. Okay, so between the framed and the natural, or the frame and the artifactual?
Frame and artifactual.
Okay, artifactual is really a standard lab, except you recruit different people. So imagine I talked about the BLESS lab in Bologna. I could invite, we generally rely on the student subject pool because we already have a huge list, a huge pool, and you know, in a way this is vetted pool, but nothing stops, and we don't do it in Bologna, but for instance at LSE where I was before, we also recruited, say, adults from the general population. So if I were to invite people from the general population, that would be an artifactual field experiments. Now, the framed one instead abandons this idea of it being very neutral and unframed and abstract to maximize generalizability, and instead makes it much more specific to the context. So it could be, going back to our examples, a fishing game like the one you played yesterday, that was framed, right? Because you had the graphical interface that really made it salient that this was about fish, while if instead I were to remove that frame and try to just give you the underlying equations and payoff functions, it would be unframed. So this is the difference. You make it really specific. Of course, you know, there's pros and cons. You make it clearer, perhaps, but you also lose some generalizability in the sense that you have to introduce aspects in the way you describe the problem or in the way you depict it that may change the behavior. So it becomes a little bit more difficult to tell apart the effect of your treatments. Does that clarify?
Yes, clear. Thank you.
Okay, thanks. Any other questions? Okay, then I think I give the word to group 11 then, if they're all connected. I already gave the rights to one of them. I think I gave it to Laura, so Lucrezia, Laura, and Chiara. Are you there?
Can you hear me?
Yes.
Okay.
Chiara, did I give you the... Let's see. Maybe not. I gave it to Laura, but I don't know, I can give it to you. I can give it to both. Okay, now you should be able to share the slides as well, both Laura and Chiara.
If not, I can share the slides.
Yeah, go ahead. Whoever wants to drive.
Unfortunately, I cannot share. It says...
I didn't give it to you. Okay, hold on. You're the only one I didn't, but I can. Okay, let's see. Okay, now you can as well.
Yes. Okay, just a sec. Share. Can you see my slides?
Yes, perfect.
Okay, perfect. So, okay. Okay, can we start?
Go ahead.
Okay, so good morning, everybody. My name is Lucrezia Nardon, and today with Chiara and Laura, we're going to present the paper Collective Responsibility Amplifies Mitigation Behavior, written by Nick Obradovich and Scott Gointher. So, we usually think that placing responsibility on the individual could be the best way of encouraging behavioral change to protect the environment, for example. But as we're going to see in this presentation, the paper shows the opposite result. So the main focus is, does collective responsibility amplify mitigation behavior, or is personal behavior more effective? So this paper analyzed 3 separate experiments to answer 4 different questions that we will see during the presentation. These are the 4 questions that we'll see now. The first question is, does placing emphasis on the collective versus personal cause of climate change produce more pro-climate behavior among environmentalists? So the first question is focused on the change in behavior in people who are interested in the environment. In this case, they interviewed by an email online survey the members of the National Audubon Society. The subjects randomly received 3 emails and they had to respond to this task. The first one was a personal responsibility essay writing task. For example, in what ways do you cause climate change? And it was focused, for example, on individual language, talking about you, individual responsibility. The second one was a collective responsibility essay, writing task, which was focused on, for example, in what ways is climate change caused, on collective responsibility, and also the language was related to the collectivity. And the third one was the control group, and it was, for example, a daily individuals had to explain their daily routine, so what they did in the morning, coffee, was the control group. So results of the question one. So after the important thing to say is after administrating the experiment, they measured the subject costly decision to donate to Audubon's climate change effort. So they told them that randomly somebody was going to win $100, and they could decide how much of these $100 donate to the Conservatory Society, and the rest would be their personal gain. So if they decided to donate $20 to the society, they would obtain $80. So the first thing is that the affiliated, the members of the Audubon Society gave a high amount of their potential winning to the society across all conditions. But the interesting thing is that the collective responsibility essay task donated 7% more than the control group, whereas the personal responsibility essay task produced no significant difference with respect to the control group. So this is the interesting thing. This is the interesting thing, as we can see in the question number 1. So collective responsibility is better than individual responsibility in this case. The second question was, are the effects observed in a sample of environmentalists consistent with the effect observed in a general public sample? So here we are doing the same exact experiment as before, only the population sample is going to change. So we can see if we can replicate the previous experiment in the general population. In this case, we picked from Amazon Mechanical Turk. The results were that there was that the first result was the personal essay task donated an average amount that did not significantly different from the control condition, just as in the previous example. And the second one was that participant assigned to the collective responsibility condition gave significantly more. This was nearly around 49% more, so nearly half. So this is a great increase. Obviously, since the participants were not affiliated with the Audubon Conservation Society, they donated more than in the previous example. But the important thing about these first two experiments is that in both of these studies, the personal factor is substantially less effective than when you take in place collective responsibility. Now I'll give the floor to my colleague, Laura.
Okay. Well, the ultimate goal of climate advocacy is to convince individuals to change their climate-related behaviors repeatedly into the future. They followed up with the sample of Mechanical Turk workers from the general population, inviting them to take a follow-up survey.
Can you, Lucrezia, can you point at the slides?
Sorry.
Perfect, thanks.
Okay, sorry.
I was saying that they follow up with the sample of Mechanical Turk workers from the general population, inviting them to take a follow-up survey. And in this survey, the donation outcome measure was repeated with an additional raffle money awarded. And the originally observed main effect of treatment on donation persisted, and subjects who originally received the collective treatment again gave a statistically significant $6.80 more than did those subjects who received the personal treatment. In the next slide, the fourth question asks whether the experiment could similarly alter behavioral intent with respect to future climate-related behaviors. And then subjects who had not completed any of the prior survey were recruited, and they were asked this question: how likely are you to reduce your own climate change causing behaviors in the future? And in this experiment, mechanical Turk subjects assigned to the personal essay task reported an average intention to change climate-related behavior that, similar to donations in the other studies, did not significantly differ from the control condition. And like donations in the previous studies, those subjects assigned to the collective responsibility conditions reported significantly increased intention to reduce climate-related causing behaviors as compared to the personal responsibility condition. Now Chiara will continue.
Can you hear me? Okay. So there are two main reasons why focusing on the collective rather than the personal responsibility. So Lucrezia, can you go
Further on, right?
No?
This one?
Before?
Sorry.
Okay, ancora?
Yes.
Another time? Okay.
Okay.
So there are two main reasons why focusing on collective rather than personal responsibility. One is the cognitive dissonance. That means a psychological discomfort experienced by who holds contradictory beliefs or ideas. So individuals in this case try to reduce their internal conflict by harmonizing their beliefs with their behaviors or vice versa. So the main point is that effort to decrease this dissonance could diminish pro-climate behaviors or intentions. The other one, so next slide, is the construal level theory. So the construal level theory offers an alternative framework for understanding why collective responsibility could motivate climate action. So in general, in construal theory, the farther an object is from the direct experience, the more abstract is the consideration of that object. So in the context of this study, individuals in personal condition may construe climate change more proximally than ones in the collective condition. But proximizing climate change construal may decrease the tendency to act on climate change because it draws attention away from broader environmental concerns that are less immediate to individual experience. Another important point is that collective conditions produce either level of negative effects, especially, for example, fear, that the personal control conditions. Individuals in the collective treatment group were motivated to donate, for example, money to counterbalance their negative emotions. So now talking about the discussion of this topic, so next slide, okay. So there are some evidence and some also limitation of these studies. Some evidence are the fact that emphasizing collective responsibility for climate change could be more effective in changing behaviors and attitudes. And the collective responsibility outperforms in altering actual behavior and intention about future behaviors. There are also some limitation of these studies. The first one could be the fact that respondents across studies believed more strongly in the occurrence of climate change than, for example, does the average of the USA citizen. And that the fact that future studies should investigate more directly on how collective framings can alter climate intentions. among those less supportive of climate action. Another one is the use of essay writing primes that also can be a limit to the validity of the findings. Another point is that the benefit from extending the time until the follow-up persist over even a longer period of time. And in conclusion, the need of further study to more discern the psychological process that underlie the behavioral difference that we observed. So other evidence are that the personal responsibility for climate change provide insufficient motivation for behavioral change, and the fact that presenting climate change as a collective problem with ways to individually contribute to its solution proves to be more persuasive. So in conclusion, just a few words about the method details. So there were 5 separate surveys, 2 that were these 5 separate surveys were via Qualtrics platforms. 2 were identical surveys for the National Open Society. Another one, after there were the first survey of respondents via Mechanical Turk, and then the other one was a survey on Qualtrics, and finally, after the follow-up study, the second main survey was via Mechanical Turk platform, and that was to evaluate behavioral intention as well as the possible impacts of the treatments on the respondents' emotions. Thank you for your attention.
Okay, well done. Well done, Group 11 and Chiara for managing to talk over the drilling noise. Are they doing construction in your flat?
Sorry.
No problem. No, we heard you. Okay, so let me ask, first of all, well done. Everyone is delighted. Let me ask question if there are questions from Teams or from Rimini. Yeah.
Yeah, so I wanted to ask if these donations to the Environmental Society were linked also with the belief in climate change.
So if the donations to the climate charity were
linked also with the belief in climate change.
Okay, so if there is an effect of belief in climate change in terms of how much people donated. Yeah, good question. Any of the 3, did you understand the question?
If I can take it, can you hear me?
Yep.
Okay, so yes, there was a certain effect. In fact, the first group, the environmentalist group, had a high belief in climate change. Around 94% of the individuals who took part in the survey believed in climate change, whereas, for example, in the second question we analyzed in the paper, the Amazon Mechanical Turk who took part in the survey, the belief in climate change was about 85%. So I mean, there's a 10% difference, for example, in the first 2 questions. So that was also quite influential for the donation, other than maybe being affiliated with the society, but also the belief in the issue.
Thank you. Good answer and informative. Other questions? No? Well, I have one. I'm curious, and this is going above and beyond this paper, but I'm interested in your perspective, since you have read this paper, because there's a literature. I don't know if you have come across it. Maybe, I think the Obradovic paper, they cite some of it, although this is very much focused on the psychology literature. But more generally, there is there is evidence, some evidence that there is a trade-off between individual and collective responsibility frames. So some of the literature, or at least the earlier literature, seem to point in the direction of individual responsibility, sort of framing it and putting the finger on our individual responsibility would increase our donations, say, or increase our willingness to contribute to mitigating climate change in some form or another, while emphasis on group level or collective responsibility would diffuse this, and then we would be less inclined to take action. Now, the Obradovic paper seems to be incompatible with this story and point to the important role actually of focusing on collective responsibility. Do you have a view about the trade-off between the two? For instance, if we emphasize individual responsibility, are we less likely to support policy at the systemic level? So I'm interested in this tension potentially between the two.
No, could you repeat, please, the last part of the question?
So the question is, given that we're talking about two very distinct type of senses of responsibility or guilt, right? Whether to do it because it's our duty to recycle, or whether the government should take action. So in the paper or in the literature thereof, have you formed an opinion about a potential trade-off between the two? For instance, if you were to stress the importance of individual actions such as recycling, could that backfire by making us less vocal and less active in terms of pushing the government for more action? I know it's not specifically related to this paper, but of course it is related in the sense that it is the potential trade-off between individual and collective responsibility.
I personally, if I understood the question correctly, I personally think that in some areas, for example, when you address people, telling them to, for example, it's a good thing to work on your personal diet, going maybe eating less meat and going vegetarian or plant-based to reduce the CO2 emissions. I usually see that there is a great, especially at the beginning with people who are not very into the environmental subject, it usually backfires and people go opposite and start saying that they are not interested. That what is the issue with soy, for example, that it's the deforestation. So I think usually especially in some contexts, which can be more related to personal habits that people don't want to change because it costs them more to change them, it usually backfires more when, for example, some issues like recycling, it's a bit less because it's not that big of a loss for an individual to recycle, whereas in some of the topics it's much more heavier.
Okay, so it's a self-serving story.
Yeah, I think it's like it depends on the individual.
How costly it is from the individual.
Yes, I think it's related to that factor there. I don't know if it's the correct answer, but
there's no correct answer.
Okay.
I just hoping to start a conversation about reflections more general than this one paper about the two types. Change is a tricky one, right? There's both elements, and
Yes.
some of the literature points to a potential trade-off. Okay, any other comments related to this or other questions? Chiara, do you have anything to add? Okay, well done. So let's take a break now and come back in 15 minutes time. Okay. I see that Dana has already loaded the presentation slides. You can actually make it bigger, Dana, if you let's see, I don't see what you see now, but there's an option to, that's it, perfect. Make it a bit bigger.
Isn't it showing it on the full screen for you?
Yeah, no, now it's good. Yeah, it's
okay.
Okay, I think we're all back, more or less. So I will give the floor to, now I think you're removing some of the content. We see all.
Oh, okay.
Yeah.
Like this is fine?
This is good, yeah. Okay, so I will start recording and feel free to turn on the camera. And I'll give the word to group 10.
Okay, so hello everyone, and today our group will present you the analysis of the question of how much can we learn about voluntary climate action from behavior in public goods games. And so, to begin with, it has been argued that findings from public goods games, or PGG, experiments with students can provide insights into the climate mitigation behavior of the general public and therefore lessons for climate policies. And so public goods games experiments, those evidence, they deliver actionable guidance for climate policy because those games make it possible to obtain causal evidence quickly and at a low cost, and they can truly provide the desired valuable policy insights. However, crucially, it depends on the generalizability. And also public goods games, they generalize volunteer climate actions, or VCA, by the general public. And so, in our paper, we take 2 steps to provide an answer to the question of how informative behavior in public goods game experiments is for VCA, in particular by the general public. And so those steps consist of testing for generalizability across experimental tasks and as well as testing for generalizability across subject types. And so these 2 steps, they not only inform about the degree to which behavior in public goods game experiments of student subject generalized to the behavior of the general population subject in those experiments, but they also highlight whether generalizability is threatened more by the choice of experimental subjects, by experimental design features, or by a combination of 2. And also there, our paper, it relates to 2 strands in the literature. The first strand is motivated by a concern that subjects' behavior in abstract games forms under controlled condition in the laboratory, and it may not generalize to individual behavior in context-free situation outside the lab. And the other strand in the literature is comparing the behavior of students and non-student samples in experiments. Also, there is a present problem of generalizability in this paper, and it relates to the deliberately abstract format of the public goods game does not capture the richer context of preference, beliefs, and attitudes that are likely to shape voluntary mitigation decisions. And the other problem is that student samples without account which account for the majority of public goods games evidence share only a limited range of individual attributes such as age, cohort, and education with the general population. And the difference in these attributes could matter significantly more in contexts such as climate change. And so to examine whether these reasons threaten the generalizability of student behavior in public goods game experiments, we undertake 3 distinct ventures in one experimental setup. So the first one is to examine whether estimates of generic operative preference derived from behavior in public goods game experiment can explain a significant portion of individual mitigation behavior in a VCA experiment. Second one is to examine within the same experimental setup whether this design of abstract public goods game experiments can be altered such that generalizability towards VCA increases. And this can be done by experimentally varying the structural parameters of the public good games. And the third venture is comparison of behavior across two distinct samples of subject. One is the standard convenience sample of students, and the other is a sample recruited from the general population. So our paper is related to several other literature. However, not of them are very so those other literature, they all lack a direct and instructive measure of cooperation in the field, and that's why our paper is designed that it identifies to what degree the correlation between the two tasks depends on the parameter choice in the public goods games, and these design elements are well suited to provide answers to our research questions with their focus on generalizability to voluntary mitigations. And now we'll talk about experimental design and implementation.
Okay. So in order to understand whether and under which conditions generalizability can be applied to voluntary climate action from PGG, experimenters observe each subject's behavior in two different tasks. Next slide, please. The first task is the real giving one, so is in which experimenters observe individual contribution to the public account, to the public good of climate mitigation. In this case is the reduction of CO2 emissions, how? By retiring emission permits from the EU ETS. Next slide, please. So before reaching the decision screen, everyone was informed about the fact that they would receive 10 euros as a reward for their participation in the experiment, and that they could use this 10 euros instead of €1 to contribute to the reduction of CO2 emissions. Then a short explanation was given about greenhouse gas emissions, and to be more specific about how much of CO2 can be reduced with a €1 contribution. Lastly, each participant were informed about the fact that the certification about the reduction would be published. An important detail is about the anchoring effect. In fact, no example of provision level were given before everyone had chosen their contribution level. Next slide, please. In the subsequent task two, starting from the hypothesis that the degree of generalizability can be affected by the choice of parameters, experimenters observe each subject behavior in 10 different public games, which differ structurally along 3 different parameters, which are the sample size, the payoff, the symmetry of payoff, and the marginal per capita return. Next slide, please. So each of these 10 different public good decision, public good game decisions, sorry, have in common the fact that of public good dilemma, in which no individual monetary incentives is given for participating to the contribution to the public account, but the group as a whole would benefit from contribution. In fact, the internal return, which is the quantity earned by each participant for each token given to the public account, is always lower than 20 cents, which is the quantity earned for each token kept in their private account. And but on the other hand, if everyone would participate, contributing to the public account, the quantity would be maximized for each decision and each subject. Next slide, please. When it comes to the sample characteristics, there are 135 subjects, of which 92 students and the remaining no students. Why there is this difference? Because the experimenters wanted to understand if the prior focus on student subjects influence the conclusion that can be drawn from existing experiments. So now I leave the floor to Alessia.
Hi everyone. I'm going to introduce some final observation. On overall, we can say that contribution in task 2 were greater than in task 1. And then students tend to contribute less than non-students. Here in the graph, we can see that in task 1. So we have first evidence that probably experiments based only on students is underestimating the willingness to contribute of a larger population. And also contribution generally increased significantly with the group size and returns, especially for the group of students. So this gives us a first insight that design choice can actually influence the degree of generalizability of standard games. Next. Okay, so the first result we were able to infer is that no significant correlation were found between average contribution in the abstract public good game and in average contribution in the real public good game of climate action. So average contribution for task 1 was about 28% and for task 2 was 34%. So averages are similar, but actually only a quarter of participants were having their contributions falling into the same quantile in the two tasks. This is visible also in the scatter plot we have here. And in fact, the most consistent behavior was free riding, as we can see in the corner of the graph. Next. Also, another result was that correlation were higher when the parameters of the decisions in the second task were resembling more the voluntary mitigation decisions. So when the marginal per capita return is low, when the group size is large, and payoff are asymmetric. So this is another confirmation that simple adjustments in parameters were actually influencing the generalizability of public goods game. Also, for the correlation between tasks is lower than between decisions in the second task. And this is probably because of two main reasons. First, the marginal per capita return probably is still not low enough to resemble actually the climate mitigation. And second, because context-specific factors which are present in the first task but are not present in the second task are influencing the behavior of people. If we do not consider average contributions, but we consider only if contributing or if not contributing, this can better generalize the results we have, especially for students. And also a variation of parameters have shown to have little impact on the correlation in free riding in the both tasks. In task 1, we got the 39% of free riders. And in task 2, we had the 13% of strict free riders, which means that they never contributed in the all 10 decisions. And out of these free riders, almost 60% of them did not contribute also in task 1, so they never contributed in the whole experiment. Out of the 300 and plus observation of perfect consistency, 64% were free riding. So again, it's the most consistent behavior. To talk about consistency, we can have some further observation, given that all the previous results were mainly driven by the consistency of choices of students. In fact, they seem to be more consistent than non-students, especially when the marginal per capita return is lower. In fact, the great correlation that students shown is partly driven by the consistency of free riding. In fact, for students, it was possible to see that they were free riding in task 1 and contributing less in task 2, which this wasn't visible for non-students. In fact, no students show a low to medium consistency and a very low correlation between all tasks, no matter the differences in parameterization. So this leads us to think that public goods game should be adapted more strongly with differences in parameters with a group of non-students with respect to students to have a similar result in generalizability of the game. Finally, a result we can have is that for students, there's a higher correlation between the abstract public good game and the real task of voluntary climate action with respect to non-students. And also, lastly, subject pool differences have more weight in with respect to the effect that actually parameters had. So probably there's going to be some unobserved individual characteristics that are differentiating the subject pools. And then for conclusions.
So the results that we just heard are can be equal to the conclusion of the paper, but just to summarize, I would like to say that students share not only a limited range of individual attributes with the general population so that their behavior might not generalize, but tend to overestimate the prevalence of selfish behavior. So as we've seen that percentage of free riders was always higher, and it also was more likely seen for students. Secondly, individuals' willingness to contribute to climate change mitigation is at least partly attributable to generic cooperative preferences assessed in public good games experiments, and it highlights the failure of standard public good games experiments to capture many factors that are candidate drivers of individual VCA decisions. And the main conclusion is that researchers should increase generalizability by decreasing the MPCR and increasing the group size, resembling more the VCA context. And that's it. Thank you for your attention. If there are some questions, we are happy to answer them.
Thank you. Well done. Good time. Questions from the audience? Or teams? Are you guys still with us? Except for the three of you. I see you well alive. Okay, let me start, break the ice. Let's see if someone else wants to pitch in. I have a broad question. Given that you belong to the student subject pool, did you think about why that is, that students behave differently and assume more selfish behavior? Have you formed, and this is a question for the three of you, but also for the class at large, but let's start with you, given that you have read the paper. Do you have a theory about why there are such differences with the rest of the population?
Yeah, in my opinion, it is because students they always have some limits with their budget. So if in the experiment they receive some money, probably they were more likely to keep it for themselves rather than give it. And usually those who are non-students, they work, so they can also spend the money and contribute it to something else, as I think.
Okay, interesting.
If I can add, I guess this is the first answer that everyone can think of, so I perfectly agree with Dana. But also in the paper, income was considered between all the social demographic parameters and everything, and it wasn't really a significant variable in the experiment. So it was more significant having children. So maybe that's more effective.
Okay, so maybe there's a story about opportunity cost of time rather than money, but certainly, yeah, certainly people that come to the lab, students that come to the lab are interested in earning a profit from their investment of time, yet you'd expect also busy people with the job doing some kind of similar consideration.
Sorry,
yeah?
I would like to ask regarding the samples, if there were some difficulties in comparing students and non-student samples.
So a question about methodological potential issues. Was it, were there difficulties in comparing the student sample with the non-student sample?
Well, yeah, there were definitely some difficulties because this experiment it didn't take into account some things as some personal things, so some beliefs or the attitude, and that was the disadvantage of the experiment, because this is kind of a psychological factor that should be taken into account, especially when it's about students who are different and yeah, have different personalities as well.
Thanks. Other questions? Okay, well, thanks again. Both teams did a good job, and we learned quite a bit. Thank you very much, team number 10. We still have a little bit of time, so given that we're probably a bit tired, it may be a good idea to do a little of gaming, learning by doing. So if you can go on moblab.com, let's do a different game. And since there's a bit of differing approach, I will just begin with the slides. It's going to be very quick though, and then we get playing. Just log in. Try to log in on MobLab in the meantime. Okay, meanwhile, look here. By the way, that's still the code for the class code CB8Y58SX3. So we have played public goods games with and without chat. We have played common pool resource games, namely a fishery situation where you decide how many vessels to put on the ocean for fishing activity purposes. And today we will introduce a game that is somewhat connected, although it's simpler, to the Kyoto Protocol game that we saw earlier on, where one is to pick a decision as to how much to invest in polluting versus dirty technology. Okay, here we are. This is also known as Judge Me Not. Let me just run through quickly the setup. In each round, each firm, I think there's going to be 20 firms, so it's going to be two large groups of people here mixed with people at home. And you're a firm, and you get to decide, I think, how to produce your tablet. You can use a clean factory, but it is more costly, or the dirty equivalent that has this social externality. So total pollution depends on how many dirty factories are built, and the more total pollution in a given round, the higher the healthcare cost arising from this local negative externality. This is the interface. You simply pick whether to go left to the clean factory direction or right to the dirty factory. And you have your recaps, as always, which round you're playing, total number of players up in the right corner, your cumulative payoff up until that round, and then your choice. You simply click on the arrows. As always, you can look at previous rounds for history. Here's how the payoff work. So your net payoff is given by the profits net of the healthcare costs arising from those dirty factories. So if you choose clean, your payoff is 1.5 to the power of the number of firms choosing clean times 10. But you see the free riding incentive because your profit if choosing dirty is 1.5 to the power of number of clean times 100. However, for each firm choosing dirty, healthcare costs equivalent to 1.5 to the power of the number choosing dirty accrue. So suppose that there's 20 of you, and of your competitors, 10 of 19 chooses clean. So your payoff, given that you were to also choose clean, in which case there would be 10 clean and 10 dirty firms, is 1.5 to the power of 11 times 10, net of healthcare cost accruing to those 9 dirty firms. So 9 dirty firms, 11 clean, and you get a payoff of 826. However, should you choose dirty and free ride, so to speak, then there would be 10 dirty, 10 clean, and the payoff is an order of magnitude larger. All clear on the setup? Okay, let's get playing then. Let's see the MobLab interface. So we will play it without chat today. Let's see, how many people do we have online? Yeah, here it is. It's in the chat as well if you are on Teams. So we'll do it. Oh yeah, I wanted to check how many people there are. So we have 15 people online, and then roughly. Okay, let's try with a group of 15. So we have 3 groups, maybe some bots. The duration is 10 minutes, 10 rounds. Is everyone successfully logged on?
No, I'm still trying to join. Just a second.
Okay. You have input the class code?
I have the code, but I don't see where I have to insert it. Oh, there it is. There it is. Got it. Thanks.
Perfect. Okay, see, people are joining. Let's give it a go, and we will get the first groups forming. Okay, so one group is full, and I'm going to wait before I add the robots so that people can join. There should be more than 2 groups, 2.5 or 3.
Professor, can you send the code again?
It's on the chat. You don't see it?
No.
Okay, I'm gonna repaste it in the chat. Let me make it a little smaller though, because it's a bit over the top. I only see now the comment before. Oh, no, this was an old comment. Okay. So you should see the code in the chat.
Yes, I do. Thank you.
Perfect. Okay, I'm going to give a little bit of help to group 2 with some selfish robots. You have about 5 minutes and a half, especially for the last group, and the second one you're still in the first round or two. about 3 minutes to go and 4 or 5 rounds to go for 2 groups. Oh, someone joined now. He or she is going to only play a couple of rounds, but you're matched with 14 bots. Same to group 3. Two minutes. All right, final minute. Okay, so we're pretty much out of time. Let's see. First of all, who was where? You might want to know who you were matched with, something that you wouldn't know in the real lab, but we can disclose here. Maybe. Maybe not. Let me try again. Okay, so this was group 1, a human group. Okay. So blame it on these people if your group didn't do well. We're yet to see that. This also was made of humans. Actually, no, only 9 humans. And then these last 2 groups, 3 and 4, are actually just 1 or 2 players that joined quite late. So they were matched with a bunch of selfish Nash players. Okay, so let's look at the results. So we can look at the graph in terms of number of group members choosing clean. This is purely payoff, so it's not actual choices. It's what you would get given that a certain number of other firms chose clean. So, for instance, if and here actually we have the averages. If 10 other firms choose clean, you still prefer to do the dirty choice because it gives you $5,700 as opposed to $859. That's what we saw in the example. Of course, both payoffs increase as more people choose clean, but you see they always have this tension. Of course, if you could magnify this difference if you were to choose different ratios, but here that's how it was parameterized. Let's look at actual behavior. You see there's a temporal dynamic towards less dirty choices, and but overall there's some persistence in both behaviors, no? In a way, so we start from an average of 6.25 firms choosing clean, vis-a-vis 8.75 choosing dirty. Round two, we see a decline in clean, and then we more or less stay there, some fluctuations, and then a gradual decline. So there's a usual tendency of the second half to be less cooperative. People learn about payoffs. Let's see what Nash predicts for a group size of 15. The equilibrium is that only one would choose clean, and the average payoff being negative 276 as opposed to negative 141 for the dirty firm. The efficient is exactly the opposite, so this is how this game captures these trade-offs. You basically have all choosing clean except one choosing dirty, which would give a much higher average payoff, including clean, but of course that one guy defecting and choosing dirty when 14 others choose clean would make 10 times as much, with an average payoff of roughly $5,000 as opposed to a loss. So this is the frustrating tension between Nash and efficiency. Let's see how the different groups played. Let's focus particularly on groups 1 and 2, given that they are predominantly human, especially 1. So no excuses for 1. This is by round. Group 1 didn't make it till the end. They ran out of time. So we have only 7 observations. The number choosing clean is efficient almost, because the data we saw before is aggregate over 4 groups, but for group 1, they start off very well with 2 free riders, but cooperation deteriorates. You get to about an equal split halfway through, then they bounce back in rounds 4 and 5. And then in round 6 and 7, there's a tendency towards more dirty choices. You see the payoffs tend to be, on average, positive for this group. Of course, dirty is always more rewarding, and the averages reflect the number of clean, right? The more clean firms, the higher the average. For group 2, we have a very stable level of cooperation, some stubborn defection, some stubborn cooperation. Of course, here we have those Nash players, the 6 Nash players that were matched with the 9 humans, I think. And then, well, these groups are predominantly bots, and we see how much dirty choices there is. We could even look at the raw data, but I think that, so that is really choice by choice, group by group, who chose what. But anyways, we don't know who is doing what, except I can reveal the scoreboard. So let's do that. as always, beginning from the people with the most negative payoff, probably those lone cooperators in groups of defectors. So I think LORPO was matched with 14 bots, hence any attempt at cooperation didn't go very far. I think also Marco was in the same group. And Diafat, so these are the one that deal with a lot of selfish algorithms. And here we have group 2 and 1. I don't remember who was in which. You see payoffs and points are positive, so that means there's been a widespread clean choice. Otherwise, if you remember the Nash payoff, that would be negative. Midway through, we're increasingly good payoffs here. We break the 10,000. Of course, these are then normalizing points that are comparable across the other games. So for the final computation of who got more points, the left-hand side is probably more representative. And here we're entering top 10. Runner-up for bronze is Job. Bronze is Marcus. Silver goes to Luca. And finally, the winner is Marianne with a whopping 46,000. She must have defected like crazy and made a lot of income that way. Okay, we're out of time. See you next week.